John Napler was a Scottish theologian and an amateur mathematician. He was the first to invent logarithms. These logarithms were known as natural or Napierian logarithms and were based on e. The exponential function is one of the most important functions in mathematics. To form an exponential function, we let the independent variable be the exponent. A simple example is shown. As illustrated in the graph of f, the exponential function increases rapidly. Exponential functions are solutions to the simplest types of dynamical systems. For example, an exponential function arises in simple models of bacterial growth. An exponential function can describe growth and decay. The function g of x equals to 12x is an example of exponential decay. It rapidly gets smaller as x increases and is illustrated in the graph shown here. In the exponential growth of f of x, the function doubles every time you add 1 to its input x. In exponential decay of g of x, the function shrinks in half every time as soon as you add 1 to its input x. The presence of this doubling time or half-life is the characteristic of exponential functions, indicating how fast they grow and decay.
Exponential functions are used for things that grow or decay. They are used throughout the many areas of science, commerce, and general mathematics. They can be used to calculate the growth of bacteria or the growth of an investment. Banks and businesses most commonly use exponential functions. They are used to calculate salaries and investments. This is evident when graphing an exponential function. The exponential function often starts very little as to almost meet with y equals 0, but then suddenly shoots upwards as the x increases. Exponential functions are just like normal mathematical functions, however they follow a different form. A normal function has x as the base, which is also a variable, and has a fixed number for its power. An example is function x equals x to the power of 2. An exponential function is where the fixed number is the base and its variable is exponent, or power. An example is function g of x equals 2 to the power of x. The exponential function can be undone by logarithms, and vice versa, and so therefore these functions are inverses of each other. A characteristic of exponential functions is the doubling time or half-life of the output. Exponential functions are very much used in real life. An example is measuring the area of a square piece of land by calculating the length of one side and squaring it. An example is one side being 20 meters, squaring it leaving you with an area of 400 meters squared. Exponential functions are useful as it doesn't follow a straight line equation, which is useful in the real world, as a lot of things are not straightforward. They are more often used in the field of physics, where the laws of the universe are complex.
The results that are obtained from exponential functions display that they can find certain growths and decay in chosen events over a period of time. If Matt bought a new car for $25,000 and it depreciates at 15% each year, he wants to know how much his car would be worth after 10 years' time. This exponential equation, $25,000 bracket 1 minus 15% bracket to the power of 10, will tell Matt that his car will be worth $4,921.86 in 10 years' time. As of conclusions from this model of exponential functions, this proves to have good use in helping consumers decide whether or not to purchase a new car, because it will show them an approximate value of how much their car is worth after a period of time, and whether their investment is a good one. Exponential functions are not only useful in decay, but also in growth. Andrew has a bank account with a certain bank and wanted to begin an investment. The bank offers 4% annual rate and Andrew begins his investment with $1,000. Andrew wants to know how much money will be in his account in 12 years' time. B is equal to $1,000 times 1 plus 4% to the power of 12. As seen by the exponential equation, Andrew will have $1,601 at the end of 12 years' time. Andrew now understands that he can invest the appropriate money in his bank account now to yield a desired amount later in time. The use of this exponential function allows this to be possible for Andrew. Overall, exponential functions are equations which help all people, scientists, banks, and money investors to approximate certain values over a given amount of time. These functions play a big role not only in the given examples, but also in the wider world.
Exponential functions and graphs can be used to study environmental and economical issues such as climate change. For example, when looking at the climate change damages as of global economy versus global temperature change in Celsius, it is observed that for a 4 Celsius increase in global temperature, the climate damages amount to about 4% of the global economy. This is an exponential function, so the rate of increase in damages increases at increasing size of temperature rise. Due to climate change, major market sectors such as agriculture, public infrastructure, energy change, tourism, ecosystems, and freshwater resources will have a negative impact. Climate change can have an adverse effect on species extinction. This graph shows the rise in species becoming extinct every 30 years. Due to the rapid climate change, there is an exponential increase in the number of species becoming extinct. CO2 emissions have exponentially risen since the industrial age. This graph shows the amount of CO2 released into the atmosphere versus the time. This will impact the environment with sea levels rising. This is represented also through an exponential graph. This makes exponential growth so deceptive that no matter the growth rate, things always start out with a period of slow growth, but then quickly change over to a rapid build-up with a negative characteristic of doubling time.
Bring the beat back.